Aaron Rodgers throws a football to Richard Rodgers upward with a velocity of 54 feet per second. Then its height after t seconds is s of t equals 54t minus 6t squared. What is the maximum height reached by the football? What is the velocity of the football at 120 feet above the ground on the way up and down? All right. So if you look at the problem, we're going to split this up into 3 separate questions. A, what is the maximum height reached by the football? B, what is the velocity of the football at 120 feet above the ground on the way up? So on the way up is going to be our part B, and on the way down is going to be our part C. All right? So I have this set up here, what we're looking for. We have the original position function, s of t equals 54t minus 6t squared, right? First thing we're going to do is find the derivative for the velocity function, right? So s prime t, aka v of t, right? The velocity. Using the power rule, we're going to have 54 minus 6 times 2t, right? Now we have v of t equals 54 minus 12t, right? So that's going to be our first step right here. Now, we're going to be looking for the maximum height reached by the football. So let's draw a graph to start out with. Let's draw a better diagram. Okay? So we're going to have Aaron Rodgers over here throwing our football. He's going to have a little cowboy hat. Okay? Now we're knowing a football is going to come in a projectile shape, right? And we have Richard Rodgers over here in the end zone. So right now we're going to be looking for the maximum height right here. Okay? This is going to be our t-axis. So at our maximum height, we know that the velocity, aka the derivative, is going to be 0. So if we know that v of t is going to equal 0, let's plug 0 in for v of t into our velocity function. So zero equals 54 minus 12t. Now let's solve for t. I'm going to add 12t to both sides. I get 12t equals 54. Now let's isolate t. And we get 12 equals, punch in the calculator, 4.5. And now we know we're working with seconds. If you reference the original problem, we know we're looking at length by time for our units, and we know the time is seconds, right? So once we know how many seconds equals t, let's plug t back into our position function because we're looking for the maximum height. So come over here, and I'm going to get s of t, right, which is going to equal our maximum, is 54 times 4.5 minus 6 times 4.5 squared. Now, using PEMDAS, we know we're going to get 243 minus 121.5. Let me just verify that with my previous calculations. Awesome. Now we know that the height of the football at our maximum is going to be 121.5 feet. Great, so let's plug these numbers onto our graph. 121.5, and this is going to be at 4.5 seconds. So at least we know our first answer. Let's move on to part B. What is the velocity of the football at 120 feet above the ground on the way up? So B and C are kind of related, and you'll see why first. Or you'll see why later. So first we're going to find out that, reading the problem, 120 feet above the ground. So we know feet above the ground, we're looking at the height is 120, positive 120 because it's above, right? So if we're looking at 121.5 is at our maximum, we're looking right below the maximum for 120. And since it's a height, let's plug it into our position function. 54t minus 6t squared. Yeah? Now, first thing we're going to do is move 120 onto our right-hand side. We're going to get 0 equals, if we move things around a little bit, negative 6t squared plus 54t minus 120. Now, let's divide everything by 6 because they are all divisible by 6. So let's just go ahead and simplify here, right? 0 equals, negative t squared plus 9t minus 20. Great. Now we're getting to look like a nice quadratic here. Let's divide each term by -1 so that we get our leading coefficient to be positive, okay? Now you could just divide everything by -6, but I just want to take it step by step. Okay. 0 equals t squared minus 9t plus 20. Quadratic. We know we're going to have to factor now to solve for t. So if I'm just going to come over here real quick, I have a nice little magic X. Don't tell your math professor that I'm doing this. Hart's professor and on. We get 20 over here, -9 down at the bottom. What are two numbers that are going to multiply to positive 20, add to -9? We're going to get -4 and -5. So we get 0 equals t minus 4 and t minus 5. Let's separate those into two separate equations. 0 is going to be equal to t minus 4, and 0 is going to be equal to t minus 5. Let's solve for t. Add 4 to both sides, and you're going to get t equals 4 over here, and t equals 5 over here. Now we're looking for the time right here on either side, right? So this should make sense. On the way up and on the way down. So we've got t equals 4, t equals 5, both on either side of 4.5, checks out. So we're looking for first on the way up. So that means if we're looking on the way up, looking at our graph, we're going to look for something between Aaron Rodgers when he first throws the ball to our maximum height, right? So on the way up could be anywhere between there. Oh, look, the time at 4 is going to be between 4.5 and our initial, right? Fantastic. So let's go ahead and plug t equals 4 into, what are we looking for? The velocity of the football at 120 feet. So let's plug it into our velocity function, right? V of 4 equals 12t, right? 54 minus 12t, what t equals 4, so let's go ahead and plug that in right here. V of 4 equals 54 minus 48. V of 4 equals 6. And now, do not forget your units. We know we're working with velocity, so it has to be a length by time, right? And we know that from the original, we're looking at feet per seconds. And it makes sense that our velocity is positive because it's going on the way up, right? Positive velocity, everything's checking out so far. Gonna go ahead and square that little guy. Now, part C. We're looking for the velocity of the football at 120 feet above the ground, so still positive, right? On the way down, right? So we know we're looking for something after 4.5 seconds. So on the left-hand side. So let's go ahead and do this guy in a different color. Let's get this one. So if we're looking on the way down, we know we're looking to the right of 4.5. Look, 5 seconds is on the right-hand side of 4.5, okay? So, well, that's a little too serious here. Now, what are we looking for? The velocity. So let's go ahead and plug in 5 into the velocity function, right? So V of 5 equals 54 minus 12t. T is equal to 5. What are some things we're expecting? We're expecting the velocity to be negative, right? Because if it's on the way down, the velocity should be negative. Now, V of 5 is going to be equal to 54 minus 60. 54 minus 60, what? Negative 6. Now, do not forget your units again, right? Velocity, same units, length per time. Now, on the right-hand side, everything's checking out. I'm going to go ahead and box this guy. Let's double check and make sure we got everything covered. Part A, maximum height, 121.5 feet. We're looking for the velocity from the ground at a specific height, 120 feet on the way up. Positive velocity, units. On the way down, negative velocity, units. Thanks, guys. This was chapter 3.4.